This is lesson 8.6, part 2, where we get to explore the world of word problems. In these particular problems, we're going to be dealing with rate, time, distance, or rate, time, and jobs. These are the infamous rate time problems. So to begin, let's take a look at what the formulas are going to be. If you take the rate, like how fast you do something, with how long you do it, gives you how many jobs you're going to get done. This is true whether you're driving. It would be the rate that you drive, the amount of time you drive, gives you the distance or how far you drove. In this particular problem, we're talking about delivery route. So the job is going to represent the delivery route. I can change this equation up a little bit, and if I need to come up with the rate something's done. So if I have 3 routes and it takes me 3 hours to do them, then I have 1 route per hour. You take the job that you have to do divided by the time you do it, that gives you the rate that you're working. So let's keep these in mind as we go through our first example. One delivery driver can complete a route in 6 hours, another in 5. If they work together, how many hours will it take to complete the route? Okay, I find it easier to do these if I start to organize my data. And I like to use tables when I organize. So let's call the first row driver A and the second row driver B. And I'm going to use my top equation here because ultimately I want to know like they're doing a job. So I've got the rate that they're working, the time that they're going to do it is going to give me a total job. 1 job. All right, for driver A, I have the rate is the number of jobs they did in the time they did it. Well, my first driver can complete a route, 1 route, in 6 hours. 1 job in 6 hours. His rate is equal to 1 over 6. So I'm going to put that in my first box. Another driver completes the same route in 5 hours. 1 route in 5 hours. His rate is 1 to 5. So again, I took the job divided by the time. Right? So the time I don't know is what I'm going to solve for. How long if they work together? Well, I take the rate, 1 over 6, and the time. Rate of B, 1 over 5, and his time. And if they work together, that means I'm going to add my 2 fractions to give me my 1 job. So I have 1 over 6, or 1 times time, that's just t over 6, plus t over 5 is equal to 1 job. So let's add our 2 fractions. Let's get rid of that denominator. My common denominator, 6 times 5, is 30. So I'm going to multiply everything by 30. Even the right-hand side by 30. Let's reduce. 30 divided by 6 is 5. So I have 5t. 30 divided by 5 is 6. Is equal to 30. 5 plus 6, 11t equals 30. Divide both sides by 11. And you get 2.7 hours. If our two drivers work together, it will only take them 2.7 hours. Our second example is going to involve airplanes flying, sorry. This is our rate times time is equal to distance. We're going to use kind of the same format of our chart to help set things up. An airplane flies from its home airport to a city 510 miles away and back. So I'm going to label my two rows. It's flying there and back home. Up above here, I've got my rates, which is in miles per hour, the time, which is in hours, multiply them together, and that's going to give me my distance. Okay, let's fill in the information we've got. Let's see, the distance going there and back is going to be 510 miles. The total flying time for the round trip flight is 3.9 hours. So my total time, I'm going to just drop below my two boxes, is 3.9 hours. That's total. The plane travels the first half of the trip at 255 miles per hour with no wind. So my rate there is 255. Okay, I can see I've got quite a few empty boxes that I need to fill in. I'm going to start with the trip there. I notice I have just one bit of missing information. I have my rate, 255, and the time, t, is equal to 510. I can divide by 255 to solve for the time it took to get to the city. The time is 2 hours. So it took 2 hours to fly to the city 510 miles away. I'm going to fill that in my box here. And time is in hours. Well, if my round trip was 3.9, 2 plus what number gives me the 3.9? That's how I can solve for the second time. My round trip minus the trip there gives me 1.9 hours back home. So it takes less time to get back home. That means I must have a headwind, or tailwind, sorry. It's pushing the airplane, helping the airplane to go faster. So that would be 1.9 hours. Now I have one box left to fill in the rate. So in my last bit of calculating, I take my rate times that 1.9 hours is the 510. Divide by 1.9, and the rate on the return trip home is 268.4 miles per hour. 268.4. Right, let's see what this is actually asking us for. It says, how strong is the wind on the return flight? Well, my trip home was 268.4. The original flight with no wind was 255. So to figure out how strong the wind is, we just need to subtract the two. Take 268.4 minus the 255 will give me how strong the wind was. And it was 13.4 miles per hour. Is this a tailwind or a headwind? This was a tailwind, meaning it pushed at the tail of the airplane, making it go faster. And that concludes our word problem section. On the last part of your notes, you just needed to circle tailwind.